Welcome to Chapter 3. Today's section is entitled 3.1 Congruent Figures. Today we're going to look at what does it mean for shapes to be congruent and how do we determine that they are. So we've got two definitions here. One is congruent polygons, and these are polygons that have all pairs of corresponding parts congruent. And what we mean by that is that all pairs of angles and all pairs of sides that are corresponding must be congruent. So if you have a quadrilateral, you have to know that you have four pairs of congruent sides between the two shapes, and also four pairs of congruent angles. Specifically, we have congruent triangles, and this is what the chapter is really going to all be about, is proving triangles congruent. In order to prove they're congruent, at least for today, we need to show that we have three pairs of corresponding sides congruent and three pairs of corresponding angles. Starting tomorrow, we're going to see that there's certain shortcuts that work for us and others that don't, that maybe we actually only need three pieces of information to do that. So we'll do a quick example here. This says name the triangle that is congruent to triangle DAB. So these different tick marks, so we've got one tick mark here, tell me that those sides are the same. So I've got ones here that are 2 and ones here that are 3. Those tell me they're equal. So what I'm going to do is highlight these. And great job highlighting there. Alright, that's a little bit better. So we know that segment BA and segment OG are the same. Then I start looking at other segments. So I'm going to look at ones that have 2. So that's segment BD. And segment DG. And I have another one, the third pair. DO and DA. So what I have to start thinking about is if I've named it DAB, that means it starts here, goes to this side, and goes to this side, and then back. So I've got to match it up in the other triangle. If I start at D, the new triangle, the one I'm naming congruent to it, better start with D. And then I've got to follow the orange segment to get to A. So if I look at my other triangle, follow the orange segment, I get to O. From the orange segment, I follow the pink segment, which takes me to B. Down here from the orange segment, I follow the pink segment, which takes me to G. And just to verify, if I go continue the pattern back to D, I follow the green segment, and I do the same thing there. So early on, it might help if you have a highlighter or different colored pencils or something like that, but to be able to highlight those different segments so you can see where the correspondence is. We've also got a property, and this is really the easiest property in the world and the most logical thing in the world, but seems really pointless sometimes. The property is called the reflexive property. And what it says is that any segment or angle is congruent to itself. Duh. Of course it's congruent to itself. What else could it possibly be congruent to? And it seems like a stupid thing to say in a proof, and why would you ever need it? Well, we talked earlier about in a triangle proof, with these shortcuts that you're going to learn, we need to have three pairs of segments or angles in some kind of combination. So without the reflexive property, sometimes we don't have all that information. So we're going to pull out the reflexive property and say, well, this segment is congruent to itself. Or we're going to say that this angle is congruent to itself. And that'll give us our third piece of information. So as an example of how this would work, right now we don't know any shortcuts, but we can tell from this diagram that we have two pairs of sides congruent. We have three pairs of angles the same. So I've got 2 out of 3 sides congruent. Using the reflexive property, I can actually get my third, and that would be segment RE. If I were doing this in a proof, I would say that RE is congruent to itself by the reflexive property. So I'm going to grab the highlighter and highlight these segments. We know that these are the same. I know that EU, oops, there we go, and ET are the same. And from what we just figured out with the reflexive property, I know that RE is congruent to itself. And if I highlight it again, it just shows up the same way. So if I'm trying to name these triangles congruent, I can really name it any way I want as far as the first triangle goes, but then I have to make sure the correspondence is there. So I'm going to pick the one on the left-hand side. I'll call that triangle 1, and I'll call this one triangle 2, just so we can keep track of the information and how I refer to things. So if I start triangle 1, I'll just start at point R. And if I follow that yellow segment, that takes me to point T. And if I follow the pink segment, that takes me to point E. And just to verify, yep, if I follow the green, I get back to red. So that's triangle 1. The second triangle is this one over here. So following my logical thought that I just had on the last one, I'm going to start with R, follow the yellow segment, that brings me to U, and follow the pink segment, that brings me to E. And to double check, if we go from E to R, yep, that is following the green segment, we get back to where we originally started. Now, just another verification that we can do, we can look at different pieces of this and make sure that they match up. So RT matches up with RU according to the name, that's true. First and second letters match up. TE and UE, let's see, TE, UE, second and third letters, that matches up. You can also verify with angles. Angle T is congruent to angle U, they're in the same position. It's going to be really important that we do that when we get to proving triangles congruent, but extremely important when we get to section 3.3, where we start to pick out pieces from congruent triangles.